Hello and welcome again to Steve's Long-Stay Workshop, and tonight I've got something rather special in here. Special as in not the sort of thing I normally work on today, but I used to. This is not a radio or a TV or a record player, tape recorder, anything like that. This is an item of test equipment. It's a Marconi TF888. Stroke 3 according to this, but not on there. Marconi TF888. And what it is, it's an AF meter and an RF meter, same thing. It goes from 70 to kilocycles, kilohertz these days, to 70 megahertz or megacycles according to this. You know, the megahertz changes over time, but nowadays 70 megahertz, those are 70 megacycles, and for 70 kilocycles or 70 kilohertz. That's the only difference there. Calibrate it to 2%, it says here, and the crystal check should be on 500 of kilocycles or kilohertz, or 5 megacycles or megahertz, depending on which one you're going to use. I'll probably go between the two here, you know, but that's me. A nice attenuator here. Yeah. Now, as of the moment, this thing does actually want to work as far as I can tell. What I've done, I've set it for maximum gain according to the thing here, like that. Okay. 5 megahertz crystal on, just in case. Yeah. And I also got to protect power and stuff on the front here. But the best way to check it, I suppose, is to switch it on. Now, initially I set it to which should be around about 10.7 megacycles or megahertz, depending on which one you're going to use. Again, I do prefer megahertz, but you know, it's purely up to you. And so therefore, before I switch it on, I've got a radio here. I'm going to switch it to FM.
That certain night.
There we go. Find a square space on the dial and hit the button and see. Nothing there. Okay. We'll go up and down a bit and see what we find. So far, we find nothing. Some millimeter, but not very much else. Now, I haven't found a circuit for this, so I'm going to be going completely blind here, and I'm going to possibly borrow some test equipment as well. But this piece of test equipment, we're going to try and restore it. Okay. I don't know how lucky we'll be with this, but we're going to try. Okay. Air power meter, signal generator, and 30% modulation as well. So it's just a thing for doing radios, and bam on TVs with as well, by the way, with this. But I don't know how it goes. Otherwise, it'll be. It has been worked on before. I can tell that straight away, because if you look on the back here, it actually has been adapted in the part. Take an IC socket, and so somebody has been in here before. whether that is good or bad, I really don't know. But we'll look and we'll find out, because that's what we do here. So, let's out the case and see what we find, if anything. Screws, by the way, appear to be held in on this, you know, so don't come out, as you can see. So I'll just loosen them all and we'll see what happens. Again, if anyone's got a manual for this, and I will be looking later on online as well, that would be very, very useful. But if not, well, we'll have to go with it and see if how we get with it. In this sort of situation, the first thing we look at is the power supply. That's the first thing, always the power supply. By the way, this is from about 1947-48, just after the war, and maybe they were used in the war. I don't know where this has come from. Jay Vince's junk, Jay also gave it to me and said, I don't know what it is, basically, but can we find out? And so I said, yes, of course, and it sat in the corner of my workbench for a while now, so I thought, well, we'll look and we'll see. Well, Jay's channel, by the way, Jay's Vince's junk. Jay is very good on the vintage electronics and also vintage computers as well, so worth having a look at that, it really is. And of course, don't forget Andy from Vintage Electronics Repair, who I also work with quite a lot. I'm in that camp, okay? If there are camps, you know, I mean, whether there are or not, I don't know, but you know, they do seem to be in it. I don't think that's right, but that's the way it is. Anyway, get the thing apart and have a look inside. Oh, by the way, Andy, you sent me a circuit diagram for a CB radio this evening. That one's come out. Okay, fine. That one's come out. Okay, fine. I put that up there with the reference. There we go. And we'll see. That means therefore that it's maybe lost the thing behind it, all in place. That one has two actually. So anyway, let's see what if anything we get. Oh well, okay, fair enough. I was wrong. So if they'll come out, then they will come out, obviously. And then hopefully this thing will come out of its case and we'll have a look and we'll see what it is and what it is doing. If there's anything like this, by the way, test equipment, it has to be right, it has to be spot on, because you're going to vary equipment with it, and so if this is wrong, then the equipment working on with it will be wrong as well. So always get these things as right as possible. It's pretty much obvious, that, isn't it? Oh, there you go, there at the right, there we are, right. And we'll see what by the way, I'm going to be having a shed soon, by the way, so a lot of stuff will leave this bench, so this bench is going to be tidier at some point, but not quite yet. That's what's coming. Right, okay, well the power supply is in the unit there, so I think that's where we'll start with it. So we'll take the thing apart completely, and as always with things like this, we start with the power supply, which is still in the cabinet. So get this out. There it comes. And take it, and we'll take it from there. Lots of caps to be changed in this, obviously, and that, by the way, is probably the oven for the crystal unit, because in these days it was that the signal, the crystal was actually kept at a certain temperature, so that's probably in there. Valves and things underneath here, but I'll just knock the camera off while I get the thing apart, and we'll look more thoroughly then. This is the unit, the main unit inside the case, by the way. The power supply in the case, I'll be putting that in due course. And this is the bit that does all the work, as it were. Connected with the plug, which was instant to get it. There we are. And also I took this off as well, because I'm going to replace this cable, and look inside there. That's the terminating unit for it. So that I need to look at as well. But first of all, we don't do anything apart from look and write down what we need at this point. So we do that. So if we turn this one round so we can look, and there you are. Yeah, it's got a few caps which need to be changed, as you can see there, TCC and paper caps which need to be changed. The look, put it down like that. You see, there's that, there's you know, the resistors are generally okay. Although I will go through and check everything with the meters and make sure. The valves, I don't know what they are. So at some point I will need to check and find out, but not just yet, I don't think. That's good. If the valves are okay, then you know they will go back. But for now, I don't know what they are, so I will change them as necessary. So caps to change, resistors to check and change if necessary, and this here, which is actually appears to be held shut by something. Now I did this screw. Ah, it's coming. So it appears to be. I'm afraid they do tend to make these things difficult to get into, but nothing is impossible, even today. Ah, it's coming, right, okay, it's coming. It's coming. There we are. And that's one side out, okay. Because it's crystal controlled, of course, it's got these so to hold it into place, so it's got to come out, but I'll do it such a way to suit it as well as we can, with one hand of course, but you know, these things that send to trials, and trials they most certainly do, don't they? There we are. Right, now underneath here, there's a valve, or the trimmers, the cap belt needs to be changed. Yeah, this is obviously the circuit which we use to check. That's the trimmers for the 8 ranges. That needs to be changed. That definitely needs to be changed. The trimmers are okay. It does need to be checked and tuned, of course, and let's see what this is. By the way, this set is actually for battery and mains, apparently 3 volts and 90 volts, but I'm going to run it purely off mains here, so you know, so these are probably D series valves if anything. If anything, what is that? Can't tell. Okay, well I'll leave it until we have to take it out. I'm only looking for now. So that is that. Okay, so that's the main unit, as it were. So yeah. So what I'll do, I'll look through and I'll take value stuff. I can do it now actually. But the capacitors will have to be changed, there's no doubt about that. About 2.2k. Let's check with 2.2k. See what that one's like as a starter. .76 volts. Like something across it, but I'll check the other way around just to see. Anything I'm unsure about here will come out. There's no there'll be no second chances with this at all. Anything I'm not sure about will have to come out. There's no two ways there. Right, it's 70. No, that's obviously got something across it, or it's gone low in value. So that one for starters. Something this old actually, it might be worth taking every component out and checking it, which I won't do as well as need to be. This should be 100k. 89. Let's see if it. Still climbing. On. That actually doesn't have that is within tolerance, that. But this one next to it has a gold band to it. This is meant to be intolerance, so we'll see what that one is. Red. Again, that's just about in there actually. So again, some will be okay and some won't. So that's something which we have to look at. Capacitors, by the way. I will not take many chances with capacitors at all, because capacitors are not exactly the bane of the devil. That's wave tree switches, but they are capable of doing naughty things, I would say. That's why I change them, especially these 7.7. But again, that should be just about right. So capacitors I'll check depending on capacitors like these. Come on, let's go around again like that. You see, like these here. These horrible little paper capacitors, they will all have to come out without fail, just like a radio. You know, for example, if that there was a cap out of a radio on an 8-port valve, I would change it without fail, and I will do here as well. So it's again, the meter, by the way, got some caps in it as well. but obviously I will check and make sure everything, because well, it's the best thing to do. So that is the main unit, as it were. Just give me a minute and I will get up the power supply, which I'll be working on first, by the way. This is the power supply unit here, and this is where you start with any piece of equipment that you don't know. Always start with the power supply first. And with this unit, actually, with it being fairly old, it's got two of those diodes. That is probably full wave, that's half wave. So to guess, I would say this is throwing out, or trying to throw out 90 volts and 3 volts. So yeah. Capacitors, well, that one is definitely going to come out. Yeah. Actually, they all are on this. I'm going to change them all. But just for the sheer hell of it, let's see what voltages AC and DC this is putting out. Nothing, okay, right. So nothing there. Nothing there. Hang on, something which needs to be shorted out here, isn't there? I don't know what. We'll see what it says it should be. Yeah, okay. Take it off again for a second, and we'll have a there's two other caps there that might well be okay. The Domino type, and they're usually okay. I noticed also actually that this radiator deck. So if we take this off, then we'll see exactly which ones, if it'll come, then we'll see which ones it should do. Basically, I think we'll check by going from the plug to the case and the chassis. That's probably the quickest way, isn't it? Right, so plug, so go to chassis. It does. Okay, fine. Neutral on the plug. Okay. So go to just one of those, thank you, not both. Neutral. Neutral goes onto there and not to anywhere else, so it's to turn it round. There we are, and it should go to one of these, that one, okay, which goes to not a chassis, but it should go, I hope, to this transformer here. Well, it should do anyway. Where's it go? Neutral. Does it go in here anywhere? because we don't need some kind of probe answer. So we can make up some sort of probe very easily with capacitor. Just do that. No, no. 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 Ah, goes there. Okay, fine. And so let's try live in the same sort of a way and see where live comes out. Okay, fine, comes it there. Well, in that case, if I look at the main unit, I should be able to find out actually if I put this this in, we should be able to work out to the C come back. So we'll do that. I'll just put this back into there, and then we'll see when live and neutral come out. There's a socket in here, down here, marked power on. It's that one there. So if I put that back onto there like that, that should go to there like that. Or maybe even like that. That's more like it. Right, okay. Now with that in there now, yeah, we should be able to see something now on the transformer. So from there now, it goes through there, back out, and it should come up on the transformer somewhere. Especially if I switch it on. Especially if I switch it on. Which is not easy with one on, but there we are, I think that'll be on. Right. So now neutral should go to the switch and then back up again, and so should line. Okay. Nothing. Oh, nothing. That's a good start, isn't it? Right, okay. So that's doing now. Okay, fine. Well, let's see if it's. Well, in that case, that's live, and so there should be something out here somewhere. Well, it should be anyway. Yeah, okay, fine. But not anywhere else. Okay. Maybe it was on before. I'll just put that back up again. There we are. Right, so now should be something elsewhere as well. Nothing again. Huh. Well, hang on. That's live, and that one, therefore, must be neutral. Is there a switch anywhere for taking to battery, I wonder? It doesn't appear to be, no. Okay, not to worry. Oh, there's nothing coming back from the on-off switch, which is interesting because the meter read something, so obviously it's getting down here but not back up here. But it must be working somewhere, because of course it the meter did actually connect. So I don't really know. Said Mavis. I don't really know. Well, that on both settings of the on-off switch there it's doing absolutely bugger all. Pardon the French. Absolutely bugger all. Tell you what, if I was to stand it up and then plug it in, yes, I know I shouldn't, but you know, sometimes it's more fun to be dangerous, isn't it? Yeah. If I was to stand this thing up and plug it in, we might be able to find out what it is and isn't doing. So that goes up like that, that goes like that, and that goes to the A2, and then it goes. So it was on and it was doing something. Okay, fine. So obviously do some. Well, I mean, I will quick look to see if any valves lighting up. There probably won't be actually, because with their capacitors, but we can see, can't we? Again there. Absolutely not. Absolutely diddly square. Nothing. Bugger all. Note. Anyway. Okay. Switch off. And what I think the first thing to do here is to get rid of that for now and sort out this power supply. So what I'm going to do is I'm going to order the parts for the power supply unit, and we'll get the power supply working and we'll take it from there. Okay? That seems to be the best way of dealing with this, don't you think? But those valves are not being lit. That is interesting in a non-interesting kind of way, shall we say. Without any form of diagram, I've rebuilt this power supply. Originally, this was meant to be used. This unit was meant to be used either of mains or 90 volts and 3 volt batteries. The 90 volt batteries you can't get anymore, and I'll be using it here. So what I've done, I've simplified it an awful lot. The caps are in it had all dried out, I mean completely dried out, and some of them had gone and put their marks on the board, as it were. So all of them came out and new capacitors were put in place. Yeah. So now it's a standard power supply arrangement here, which you can see. I hope you can see there. Can you see that? Can you see that? I think they can. I'll just okay, right, okay. So that's what we've got. What we've got here, you see now. I'll use something mixed to point with. There we are. The screwdriver. There we are. Hang on. How about using this one here? Okay. Right. So there you are. So there's here is the unit. Live and neutral and mains. Three cord cable coming in, live, neutral and mains, into one transformer. Out of it, they take two windings. One for the HT and one for the LT. Yeah? The HT is 90 volts, and it goes to two diodes, but in a sort of like bridge arrangement of the time. Two capacitor, two capacitor, and then 90 volts come in. It's slightly more actually because it's not on load, but that's okay. Now, the 3 volts is a valve involved inside the unit. One of them I know is 3 volts because they are the one that's used for the oscillator. Now, with it being a unit to be run on batteries as well, it uses the B7G D series valves, which as we know are prone to failure. And so again here, transformer, diodes like before. First, where's the back capacitor, under ohm resistor, I found that by trial and error, another capacitor, a choke, another capacitor. Extra smoothing, and that is because those valves are meant to receive DC. Here, the AC has to be smooth with what you've done there, and also with these valves being a little bit more prone to failure, shall we say. As I said before, look at them when they fail. I'm also going to put in a diode. A diode across the heater chain so that it can't shoot up. As it is, it's 9 volts off load, but that shall come down. So that is the power supply built up exactly as it was before, with new parts, but not with the switching for the batteries. Okay, so that's the power supply done. If we go back to it again here, you see, these are the diodes here. That one there. That one is for the heaters, and that one is for the mains. Yeah. So that back to deck there, goes to deck there, and the rest of it goes to deck on the other side here. Now this connector was initially across there, but caps are there now, so I've moved it across it. It's still work okay like that, and so that is now ready for action. Now I won't plug it into the mains just yet, with the rest of it attached. What I will show you what happens with it now, with it not attached to anything, because you know this is the thing offload. You'll see also from this why I use a diode, and then a diode. Okay, so if you plug it in, I hope it doesn't go bang. It hasn't. Now, if you look on the HT side, this would have, that was outside. There's fireworks tonight, by the way, as well. We should have on it there. Okay. Maybe more chance picking up. We do there. That will drop on load, as will the other one, which is here. 9.3 volts off load. That's a bit high, so I will be putting in a Xenon diode to lower it down. But that's the power supply, ready to go into the unit when the unit goes back together. And the diode I will put into it itself, so that you know, if anything happens up here, that diode will save the day. We will anyway, but I want to keep it out the way from here, because if anything happens up here, that diode must really, if possible, survive. So it will go on the board down there. So it's the power supply, and now the rest of the unit. Now the rest of the unit, again, I'm not going to circuit for it, but I know from the post receiver test information that they have got, that it works from 70 kilohertz to 70 megacycles, which we can do, and stages, and also there's an AF unit as well to provide modulation for ACs for AM at 30%. So I'll do that as well while I'm at it. But an oscillator is basically an amplifier that oscillates. And that sounds a bit silly, I know, but there's an old saying in the trade: amplifiers oscillate, oscillators don't, and it's true. So the next thing is getting that to oscillate rather than amplify. Oscillators basically, the simplest way to form oscillator circuit actually is get an old tape recorder or a new one or whatever, and put the mic in front of the speaker. Yeah. It will howl around. That is a form of oscillation. That's what it does. So an oscillator basically is an amp driven into feedback. That's all it is. Yeah. And so I've got to find a way of controlling the feedback as well, which we do down there. So what I will do, I will look online for the valve that's in there and find a circuit based on that, and use that with that circuit down there. I noticed actually that the trimmers for every of all, I think it's 8 ranges down there, so I need to check those as well, make sure I get it mostly to where I want it to be, and then of course I'll use a scope and this, and possibly a frequency meter. If you're not got a frequency meter, by the way, you can also you can to some extent estimate frequencies with a scope. I'll show you to do that. Maybe not in this video, but in a later one. 3, 2, 1, go. Right, well, 3, 2, 1, go. This is the rest of the unit, and the oscillator circuit is with this valve here, which is a 3S4. So that, of course, is has got a DK number, I think, or a D something number. I'll look for that in a minute. But before we do, first thing we do is look at the valve socket here. That's just coming through okay. Yeah. Then The valve itself, by the way, with all these valves, it is the same way to check them. You just do it across the bottom 2 pins with your meter quickly, and you shall get a reading, or a bleep even. So we'll do that very, very quickly. We'll do that. Okay. There we are. So the heater's okay on that. Okay, well I will now of course go and have a look for that valve and see. But also what we can do, that's the earth. Now that is the heater pin. Yeah, it goes somewhere else through that coil. And it should go to 1 pin on here. I think it will probably be that one there. Okay, so that goes there. So that's okay. So we know therefore that that's okay. Now also in this unit there's a few things which need to be changed. That capacitor there is one, if we change it, that I'll check and I'll change it. I'm not so sure yet. Looking on the other side of the panel, there are some which need to be changed and some which I will give the benefit of the doubt on for now. Okay, because this doesn't have any audio power amps and speakers, so you might be okay with that. But yeah, so but there are 1 or 2 on here which I think need to be changed as well. Here, if you look here, you see that is the tuner, the dial selector. And if I put the thing up so you can see it like that, can you see that? Does that help at all? Okay, yeah, it does, right. That's the frequency range there, and it's tuned here. Okay, see, dial spins round. So a different one of those caps is used. One of those is used here to generate the signal required. Oscillators, of course, are included, and also this here to check AHT and LT and everything else. That's the that comes out, and it comes out here on this here, which goes to this thing here. So that I'll do as well. But first of all, it's time to go and look for the circuit and see what it is and how we can sort it without a battery, without a circuit diagram, which you can do. This is basically nothing more than a valve offset circuit. There's plenty of those online, so have a look. By the way, the valve, by the way, like I said, it's a 3S4. Now a 3S4 valve, hang on. Why a computer always slow when you're in a hurry? Why? It's one of the great mysteries, that, isn't it? It's a DL92, so obviously it's being used at oscillator circuit, and all the details are on here for that. So yeah. By the way, it's used for audio output as well normally, but in this case, what happens is that the audio is fed back to the input grid, and that is how it oscillates. So that is what we need it to do. So that will go somewhere safe for now. Somewhere safe, and we'll get back to it when we got the circuit sorted and checked for it. Now, as far as taking the circuit is concerned, it's fairly simple, but at the same time fairly complicated. There's these here, there's caps here, but I think all this, by the way, is normally inside this to shield it, the right way around. So that is normally inside there like that. You see, you've got these here to yield it down, but for now I'll leave that off because I'm going to work under there. Yeah, so yeah, the brick capacitors, that's these Lego brick ones. They tend to be okay, they're usually okay, but like I said, also while I'm here, I'll have a look and see where the HT is on this and where that goes as well. So the HT on this goes to 2 pins. It goes to pin 6 and 4. Pin 6 and 4. And so now, as far as these go, how to measure them, put the valve towards you and count from the left of the gap. 1, 2, 3. So it's 6 and 4 is the top one. So 6 and 4 are the two we want, and they shall go one way or the other to the HT, which is here. So that's our next port of call. But I do this before I power it up, by the way, because 3 volts going anywhere it shouldn't wouldn't cause a problem. But let's say that 8 volts certainly would. 9 volts certainly would. And well, so that goes on to there, and this goes on to here, and we should well, that's the anode. I think that's the anode. It is, yeah. So that should be the other grid. Which might be higher up because of course it's try that again. Oh. It is high up, isn't it? The cap on back in there, by the way, that looks as though it should be about 47. It is about that. Okay, fine. So that is okay. I might change that cap, that resistor. I don't know yet. We'll see when the thing goes together and see if it oscillates or not. If it doesn't, that's one protocol. And of course, this is the staging question that we need to get going first of all. There is also an oscillator stage on this, by the way, for the audio as well. But first of all, this one here. Thank you very much, by the way, to Restoration 73 Tony on Paul Stenning's forum, vintageradio.net. Of course, it's chat forum for vintage radio and the like. They actually got me a manual for it. It still wasn't right then. I've got it here. And first of all, the valves in it are right. I didn't know that. And what it does, I've got a circuit for it here. So therefore, I can do this in stages, which is probably the best way to do it. So I'm starting with the RF oscillator stage here. I've not done anything drastic with it. I think it'll probably be okay. I'm going to leave it as it is for now. I've oiled all the knobs and things on the front and inside gently. That's okay. And changed one capacitor on here, and also I'm going to put the diodes in as well. This is actually it's a modulated signal generator, Marconi switch on or off, and also it's got some crystal markers as well, which these actually come in to me. They look a bit like B7G valves, but they're not, although they go in the sockets. The crystals do in fact go into the sockets themselves. I'll just get one out for you to have a look at, slowly but surely, as always with these things, you know. Slowly but surely wins the race, allegedly, you know. Yeah, so yeah, there's actually 3 of these valves in, and I've also got on the circuit here also the pinate for these valves, the 3S4s. I'm surprised that 3S4s will go as high as they do, but you listen to something every day, don't you? And that obviously is mine for today. That's not going to come out, that. So I'll not force it, because I might do something stupid with it if I did, like, you know. And I don't think I will get another one of these, so I think I will leave that and the other one where they are. Basically, they are valve cases with crystals inside them. The two are in the same circuit, which I can show for you here. Yeah, that's a circuit for it there. The crystal oscillator is that bit there, and it's switching between the two using another 3S4. Anyway, with that in mind, whilst I'll put the Zener diode in, and then of course I will check the voltages, and then we'll try it. I've never worked on anything like this before, so I'm learning along with you here. Maybe you know about it more than I do, I don't know. But it looks very simple, and with anything like this, divide it into blocks and do each block in turn. I've done the power supply, that's okay. The meter circuit is here, that's leave it as it is for now. And hopefully this will. I've also, like I said, taken away the ability to use 3 and 90 volt cell batteries, because you won't get those now, and it'll be a workshop unit anyway. So that I have taken them. Nice circuit for it. The power supply is the same as the one that was here, although again I've simplified it. And yeah, so hopefully it'll start to work soon. It's the interesting thing actually, and maybe this will be a very handy alignment tool as well, but we'll have to see. We'll have to see. Right, now at this stage now, I don't know how much of this you'll be able to see, but to take the word for it. Okay, the power supply works okay, and the valve heater on the HT, that's fine. 100 volts on the HT, which is a bit high, but it come down, and about 2.9 on the valve heater, which is near enough to 3, so that's okay. Now, the thing we're going to set up here first of all is the signal generator stage of it. First of all, we'll see if it's running. And we do this because there's actually 200 meters on there. Switch it on. The meter here on the front, the meter again you won't be able to see, jumps up to max. Everything's set at maximum here. And now. 200 meters. Okay, well thereabouts. So that's okay. So now we go back to range 1, and we go and check up all the various ranges and make sure they're all okay. So number 1, 70 megahertz, and that's about 68, 70, 70, 70, 70, 70. Okay. That's about 70, right, okay. So if we go further along, we go to 100 kilohertz, this is, sorry, 100 kilohertz, and nearest damn it, 100 kilohertz. I can't set this up properly because I've not got the kit to do it. I won't be able to get the kit until after lockdown, so I'm just doing a quick switch to making sure everything is okay. And 200 and again is about 200. So again that should come through on here, which it does. Okay, does it prove that?
It's depressing.
Unplug.
So yeah, I'm doing it for my members.
Plug in. And there it is. So that's okay. Right. So now, what we need to do now is wait until this, and that of course will warm up for about 20 minutes or so. Now, while I'm waiting, I'll tell you why the kit has to be terminated properly. It isn't yet. It doesn't matter for this, but it will do in the end. This goes on the end of the lead from the unit. The cable that's in it has been replaced, so that got taken apart, and the end of this cable's got to fit into this. This has got resistors inside. Now, this system here, it has a 75 ohm load. Okay, 75 ohms. Yeah. Now, with a system like this, see if I can find a bit of paper and a pen. Hang on. And then I'll bring the thing a bit closer. Hold on. Right, now then, first of all, range 1 is at 70 kilohertz or thereabouts, 79, and that goes up to I think it's 200 or so. So we go up to 200, like that, and that again is well, no, that's more or less okay. Right, range 2 goes from 200 or thereabouts, which we had before. Okay, that's a bit more like it there actually now. Come on, do it again. Thank you. There you go. No. We'll go up to I think it's I'll very quickly, first to do it, I'll check around 450 because that's where the IFs are, so about there. Let's see what that one does. 444, okay, fine. 450, 455 maybe. Come on. Yeah, that's about right. Okay, and that should be 600 or thereabouts. It is. Okay, fine. Range 3. Therefore, is from 600 about there. Okay, going up to I think it's 1.5, 1.6, 1.5. 1.5 is there or thereabouts. That's okay, fine. That's okay, fine. Range 4 is 1.5. If it'll work. That's range 4, 1.5. By the way, also, because this line is not matched, of course, this level going to this will vary. Anyway, that's 1.6, that's about, okay, try that. Okay, 1.5, going up to 4 megs. Okay, that's 4 megs, or should be thereabouts. Come on, settle down. There you go, that's about 4 megs. Okay, so therefore the first 4 ranges are okay. Now on to number 5. Number 5. Right, number 5, of course, is at the top here, and it goes from 4.5 megs, which is there, going up to 10 megs, which is there. Okay, that's there. Okay. Going a bit further, actually, I wonder if we can get 10.7 out of it here. Oh, just about, touch more. So just about get a 10.7 right in this go. That's handy to know. Right, so the next one, of course, is number 6. And number 6 goes from 10 megs, which is about there. Okay. Again, I'll look for 10.7. That should be about there. By the way, this scale is not terribly marked out, so when this was made, VHF wasn't a thing. So yeah, going up to that should be 20 megs or thereabouts, I think. Okay, maybe not. Glasses. House of red, that's 15 megs, that's 15 megs. House of glasses, I'm done to it, going up to 20 megs, which is about there. That's okay. And 21.4 is ready, which is twice 10.7, which is a handy one to know actually, because particularly in the PMR world, 21.4 megs is one which we use, so that's something which we need to find. So let's see if it'll do it. Getting there. How about that? $21. Okay, fine. We're nearly there. Okay. Range 7, therefore, starts at 20 megs, which is about there on the scale. About there on the scale. Yeah, 1 point. That's okay. Yeah. So 1 point should be something like there. Come on. Okay, a bit more then. How about that? How about there? How about there? Is that 21 megs? So 21.9. Okay, so it's round here. Okay, 10 points. So probably about there. again, I can't do this properly right now because I've got all the kit and I can't get to the kit until after lockdown. So this is just basically having a look and making sure that it basically is all right. 25 megs, that's fine. And this one goes up to 40 megs, which is about there. Okay. Then 40 megs, by the way, and upward is of course channel 1 of 405 lines, so that's handy to know as well. Okay, and finally number 8. This is number 8. Number 8, yeah, okay. So number 8, therefore, I noticed, by the way, with this high up that the meter's leaping about quite a bit. This is probably because of the yeah. So anyway, that should be 35 megs. It is, okay, fine. That's 35, okay. That should be 40 again. Okay, fair enough, don't then. Okay, 45 megs. We've got a problem here. We've got a problem here. Have we come across a problem? I think we might have come across a problem here. Right, that should be 50 megs. Which is 50 megs, okay, fine. Okay, so basically up it here, by the way, the fact that this line is not terminated will of course affect the output, so that's probably why. And of course 70 megs at the top of the band here, which shall come through. It shall come through, and it does. So therefore, these bands do work, and they are at least workable to an extent. So at this point, therefore, this is working pretty much fine. So at this point, therefore, for the moment, I'll say that the AF power side of it, the RF generator side of it is done. So the next thing we've got to do is get this off the bench, and then we've got to terminate it with this thing, which is our next job. So I will get on to that right now, and thank you very much, Andy, for allowing me that. It's very useful. Thank you so much indeed. Right now, as it stands, this is open circuit, yeah, which is why the meter was going up and down, and why certain areas of it didn't appear to be. It did, but the signal was bouncing back from this down here. So at some points it was there, and at some points it was very high. Now, the thing at the end is this thing here. It's a Marconi instrument TM888, I think, and it's a termination unit for here, which I've got to get apart because I've got to get the cable soldered into it. It's this here, yeah. It's first of all got a high output, which we'll be using, and an 8 ohm output there, which again we will be using. Yeah, I know it's only a 5, but for some reason it's 8 ohm. It's okay. Now inside here there are 4 resistors, yeah. And so first thing I do is look and try and find them. Okay. So then of course we've got to look and find out where the cable connects. This is the unit in question. I'll just hold it up. There you are. There you are. That's the unit in question. It's certainly going to need some serious sorting out. This black bit here. This black bit fingers there, that comes off, and the wire solders on underneath there. And so it's one of those jobs which is simple in practice, but probably very hard in real life. So I'm going to shut the camera off so you don't hear me swearing my head off, and put it on and come back to you in a moment, in your time, but God knows how long in my time. I'll put this thing back together again now, with a lot of swear words and a couple of total resistors actually, and I am now looking at the 200 kilohertz again on it. There we are, and of course if we go up the other end, up that way, we should get rather more. 68 there, 6 kilohertz there, and now there should be rather more. I think it's a bit deep. There, try that. That should be a little bit more when it comes down to counting it, which is not doing. Oh well, never mind. How about that? There we go. That's got the other end of the dial like that. Best, by the way, the valve on the oscillator side of it, I think, is a bit weak, so that's probably why it's doing that. But there you are. There's the other end of scale 6, scale 7, just in case. There we are. Scale 7. Come on, do it. I'm to look round because, of course, I've got these things at up so you can see it rather than me. That's not doing anything, that is it? But the scale is, so I think it's working, but this may be on the low output, so it's probably why. So anyway, it is working where one would need it to work, which is really the most important one. That's 65 there again. So it does work. And while we're at it, by the way, also on this there are 2 crystals inside it as well, which we check by going on this crystal check on earth up here, like so. So that's off now, so that should be off, right? So 500 kilohertz. That should come out top. It does. And 5 megahertz, which is nearly there. So they're okay as well. So the signal generator is okay apart from the very top end, and the crystals are okay. Now after that, now the only other thing on this which we need to check, of course, is the AF power meter. So check on that, and then we're I can't say home and dry, but I'll have to leave it because, of course, I need to someone with the equipment to help me calibrate it properly, which I haven't got here. But it'll be working, so that'll do for now. Right, well, here's the circuit, part of the circuit of the AF power meter on here. Comes in there, capture deck, through this transformer here, through the impedance and wave change switches here and here, to rectifier to point F there, okay? The point F simply goes straight to the meter if the check switch is in the right setting. As you can see, as we'll see, somewhere like there, you see that's the meter there, and it goes straight to the meter. So again, that's a maximum feed better here actually. So it goes straight to point F there, and straight to meter. So that's that. So basically, we're looking at this little circuit here from earlier on. So now, with that in circuit, now we now look at the circuit. And first thing I'll do, I'll get my meter from this place I call the bench. Ha ha ha. There you go. And hopefully we can I can get that so you can see it. I've got a minute on that one. because any meter with an ohms range we can do for this very easily. So we can. So air power is this one here. Air power, that's it, one there. And this should therefore be, we'll switch on the meter. Switch on the meter, right, and it goes just to all through the induction. So there to there, this should be some inductance, or we should be able to measure it on the scale here. Let's get that meter probe to hang in there. By fair means or foul, as they say. There we go, so that's in there, and that's fair means or foul. And so it goes from I think it's 4 ohms. Hang on, 4 ohms. It's saying 1 on there, but the meter on the front says 4, but this is different. And it should go up now, which is not doing. It is a bit actually. To 10 ohms. Okay. But then again, that's the transformer side of it, so that is probably okay. I'm going to leave that and say that is probably okay. Now with that switch up as high as it'll go there, yeah, the secondary we can test fairly well by going across R13. If you look at the circuit here, you see R13 is directly across the secondary of this transformer here, which is what we'll do. So that goes onto there like that. It's what these are called goes onto, you see. This goes onto that, you see. The code goes, never mind. And that should go into there. And we should see 64 ohms. No, that's okay, that, because of course, looking at the circuit again, you see, with the circuit diagrams, really, and R8, R9 and R12 together come to rather above that, okay? So therefore that's okay, yeah? Now from that R14 and R15 go to rectify valve from one half of it, and so R13 itself, by the way, is 400 ohms. So yeah, so going onto rectifier, onto the rectifier here from there now, we should, the rectifier therefore goes via R15 and of course the deck blue. So if we go onto R15, one half of it, we should see about, it says 7.5k, so we'll look and see if that one is okay. R15, now R15 on this circuit here is this one here. So let's see what it says for itself. 8.76 on one side. That's obviously about right. So that's okay. It's not perfect, but it'll do. So that's getting there. So that won't stop it running. Okay. So yeah, that's R15. Now R14 is next to it. Is it? No, it's not. It's on this side here. So R14 therefore to R15. One half of it should be a dead short. So we'll look for the dead short first. Okay. So that goes on to there like that, and one half of this resistor should be dead short to it. And one half probably won't be. So you know that's there. That's there. We're on to the other side of it, which is there. That's dead short. So from there to there, that's R14. That's 2.42 kilohertz. R14, which is 405 ohm. Maybe this is in the word there again, I don't know. So the next place we look, the meter, by the way, it does read actually, even with the unit switched off. I can demonstrate that for you now actually, because if I stump this up like that, that goes to AF power, or one of the others. One half goes to deck, which is easy to do, like that. And the other half goes onto the bridge rectifier, and there you are. We work straight away. You see, so that's okay. Okay, that means this meter is okay on both settings here. Okay. So the next thing we're going to do is check and see if this rectifier is or is not doing what it should. Now again, looking at the circuit here, you see the rectifier, like I said, goes from blue, which is R14 and R13, one half of it, and the other half goes via R15. So we'll find out which two of those again and take it from there. Right, so R14 and R13 are next to each other, and one, and we're looking for, in a way, the junction of the two. So that's our 13, and this one should be R14, and one half of it should be dead short. There you are. Okay, so that's obviously is that half of it. Okay, the other half of it is R15, which is over here again, R15. So R15, that reads okay, fine. So it should read okay. Now, even I can be complete idiot sometimes. Of course, a DC meter probe will not go through a transformer. Not possible. But what can I do? Well, this machine does have an RF meter, RF signal generator, which goes down to 70 kilohertz, but not too far away from AM, and so I use that for testing. So basically, what I do is I put the RF tester in there, put volume up full, and impedance low, 10 milliwatt setting, and see what happened. This means therefore that the only thing between the meter and here is of course R12, but not actually, it's simply R15 and nothing the other way, but R14 is a cross and that one is there, R30. So with that in mind, because there aren't any capacitors in this at all, it should be able to read something at RF as well, enough to tell me that this thing is working anyway. So that's what we'll do. So with that out the way, and that round a bit so you can see it, I'll just adjust the camera so you can. Hang on. Now, with it zoomed in on the meter here, you see, and set for power meter, to plug it in like that, it should. There it is. So it's working. So the system here is actually doing something. Now at this point with it, I just knock that off. I've got it on 3 ohms and 10 volts, which is supposed scale. It does read on a higher scale as well, but the meter reading goes down. Obviously, it looks like it's up because the thing's upside down, but the meter which really does go down, because now, as you can see, it's off. So basically at this point now, this thing is, apart from being calibrated, working on all bands. So that's what maybe all I can do, because until COVID's over, I can't get it down to anybody's to calibrate it properly. So I'm not going to. But now I know the thing's working, the power supply has been modified to suit modern standards as well. But we've now got to start putting this unit together, which should be something itself. The unit is here, the box is here, and as you can see, there are certain things which I need to sort out with it to make it work okay. So next time you see me in a minute, this should be together. Well, here it is. It's a Marconi TF888 postal receiver tester. It's working on all bands, on the FMs, on the RF scale here, and on the crystals, and the parameter, which we've seen it all working. Yeah, I can't calibrate it yet because I've not got the kit to do it here, and I can't go to where it has because of COVID. So, but as it stands, I can use it to align stuff, but not measure it. You see what I mean? Because I can set sort of maximum or the minimum, but that's it. Yeah, this thing is an AF parameter, there's an RF meter and a crystal checker, and between them you can check every bit of a radio receiver, AM or FM. AM, yeah, AM, it doesn't actually have an FM modulator in it, but you can do it with AM. They're using slope demodulation. So there you are. So it's works on all bands. So I'm going to put this away now, and and I'll be back with it actually when COVID is over. I go and get it calibrated. Then I can use it. Now looking at this now in 2020, the year of the COVID, this goes up to 70 megahertz, and that might seem a useless number today because it doesn't go up as high as the RF band does. That starts at the VHF band. That's off at 88. But in those days, TV was done on 45 or 50 megahertz on band 1. Rest of band 1 and ITV on 20 megs hadn't started yet. So really, it's an AM receiver with up to FM and nothing more. That's really it. And so, in its day, it was probably very, very useful. And it is now, but not as much as it was, because you can get stuff that goes up to 200, 250 megs for band 1 and band 3, or for UHF up to a gig. That's how far it goes now. But it is what it is, and it works. And so there you go. This is a Marconi TF888 portable receiver tester. Works on all bands, and it'll help me fix radios in the future. And so until next time, goodbye, and of course may God go with you whoever he is, and keep fixing radios and TVs and tape recorders and the generators. So until next time, this is Steve Pendlebury saying goodbye and God bless, whatever God may be. Bye bye.